Hi, this is Stephen Brower from Irvine Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language, and this is meant to be the chapter overview for Irvine Chapter 5. So one of the videos that will occur later is going to talk a little more detail about the runtime stack that we have access to. Have just sort of a glimpse at it over here. But if you remember a stack from data structures, it's a pile of data where the axis is only from the top. We push to get an item on top of the stack. We pop to remove an item off of the stack. And we have a logical pointer called the top that points to the top of the stack. Well, the runtime stack that we have available to us that we're going to use in assembly, it's an upside down stack. And what it just means is has to do with the way the addresses are arranged. And in the old days when we had DOS with a single memory, the stack would come down from the top. The data and the programs that we use would come up on the bottom. And if we were using up our data in our memory and our stack got to the point where it met our data and our instructions, then we got a stack overflow because there was no room left. Well, even though now we're in protected mode and each application potentially has their own 4 gigs of memory, the stack is still descending from the highest address down. And so if we look at it, and by the way, the ESP, that's a register that's on the CPU, and it has a pointer logically to where the top of the stack is. When we do a push, the value is put onto the stack. So if we do a push EAX, and EAX has the value 8, then 8 is put onto the stack. ESP advances by decrementing. So if this is the address, that initially was of this one here, this is, if you notice, it's one less. So the top moved, the ESP moved, it's just the value in a sense has gone less. Later when we get to chapter 8 and we deal with stack parameters, if we're pushing multiple things onto the stack and we want to get to the prior thing in the stack or the one before that in the stack, then we actually have to use increasing numbers. Again, that's a foreshadow to chapter 8. So there will be a video that will go in much more detail than what I just did. One of the things that a stack also is used for is a nested loop. So the nested loop that I didn't show you last week or in the prior chapter, we'll go through the nested loop this week because the stack lends itself very well for preserving ECX. Although we're going to focus on creating procedures in chapter 8, we'll see the process, and the cheat is that, remember the template? The template actually has in there, if you look in the .code section, there's main proc, and then at the very end, there's main end P, and before the main end P, there's exit. Well, what we'll see is for creating a procedure, the name of the procedure, proc, the name of the procedure, end P, but our procedures will, the last thing of the procedure will be a return to recall back from where we came. So we'll see a peek at creating procedures. There'll be another video will go into that. Documenting procedures, well, for those that have me for data structures, remember how I was harping on about the java.comments for methods, showing the @param and the @return? Well, what we're going to see is to document procedures in assembly, we show the inputs and we show the outputs. Same thing. So a description of what the method does, or what the procedure does, what inputs, what parameters is the procedure expecting, what outputs, what data is the procedure returning. We'll take a look at what goes on behind the scenes when a call to a procedure takes place in terms of the memory. And what happens is there actually is, when we call a procedure, there's a push onto the stack. And if you have a runaway recursive method and you get a stack overflow, that's why. Okay, let me just jump to the end here. So the latter part of the chapter, the Irvine library. So we actually have been using some of the Irvine library up to this point. Called dump regs, or the dump regs, has been one thing that we've probably used a lot. Hello World, we saw right string. And the book itself is really meant to be the reference manual for the Irvine library. And what the book will have is it has a description of the parameters and the output that procedures have, and we'll have one example. What I have up in Canvas is I have sort of a quick reference guide that just lists the inputs and the outputs, doesn't necessarily have the examples. And that's enough for an overview.